Properties of bonding lab. Today we are going to be looking at 5 different substances and trying to determine the types of bonds that each one of these things has. And so in order to do this, we're going to be looking at things like conductivity and melting point to help us determine it. You can also use some sort of visual cues as well, but that's not the only thing that we're going to be looking at. So if we take a look at the directions here, there's a few pre-lab questions that it's going to ask you to give us some definitions of some different things like malleability and conductivity. But what we want to do now is first we basically want to make some observations about each of the individual chemicals, and then we want to test their conductivity both as a solid, dissolved in liquid, and then the melting point. So taking a look at chemical number 1 here, see if we can get this to focus. There we go. We can see chemical number 1. Kind of roll it a little bit. You can see it's sticking to the sides of the glass a little bit. So you guys can make some observations about this guy. All right, the next thing that we want to do is try and test the conductivity as a solid. Now, to test the conductivity as a solid, what we're going to be doing is we're going to be using this conductivity meter. And the conductivity meter is basically going to give us a ranking. It's ranking the conductivity on a scale of 1 to 10. So typically what we find is that in order for something to be conductive, it usually wants to fall, in the 3 or larger category. Technically, according to like a book definition, any little bit of conductivity would mean that the substance is conducting. So even a 1 would qualify. However, what I've found just through experience is that items that are not supposed to conduct oftentimes will give a small, tiny little bit of conductivity, mostly just because our glassware is not clean and we have residues left behind. Plus, there could be little bits of tap water and things like that. Tap water conducts electricity really, really well. So what we do is there's a little button on the side here, and when you push this button, we get a little red light indicating that the unit is on. You'll notice that there is no red lights coming on here. It is nothing is conducting, because what we're testing right now is the air. We have electricity going down one pole, and when it can go back up into the other one, it completes the circuit and we get a light that comes on. But the electricity can't jump through air, so air is not conducting. So when I submerge it into this substance here, so it's not able to travel through the substance as a solid. And so we would say that this one is not conducting electricity as a solid. So this would be a no. All right, now what we want to do is, do we want to do it as a liquid yet? Yep, we do. Let's do it as a liquid. Now, for the liquid, we're going to be using distilled water for that. And just to kind of test and make sure that we are using distilled water, traditionally what you would want to do is get a clean beaker and test just the water. Because occasionally when you buy distilled water is not supposed to conduct electricity, but occasionally because of impurities or somebody accidentally in lab maybe refilled the bottle from the sink, so they have tap water in there, something like that, that could really mess your data up. So we want to test the water first. So this should not conduct electricity. Let's double check that it does or doesn't. So we're going to go ahead and put a little bit in there. We're going to wipe off the ends of these leads since it was just in a substance, and we want to submerge it, and hopefully we don't get any conductivity. And so it looks like we've got it submerged nicely in there, and we're not getting any lights coming on. So this is good distilled water. So now what we want to do is we want to see if this substance will dissolve and then conduct electricity. So we're going to go ahead and just dump that water in there to save some. We'll give it a stir or two. Let it get a chance to dissolve, if it will dissolve even. So it looks like some of it's going into solution. Let's go ahead and test number 1. It's conductivity when it's dissolved in liquid, in water. So we push it in here. Looks like we're conducting quite nicely once we dissolve it in water. Okay, there's our first one. Let's go ahead and take a look at our second chemical. So our second chemical here, go ahead and make some observations on that. We're going to go ahead and test the conductivity as a solid. So we're not getting anything here. Let's get some water into it. And let's test our conductivity in water. So we've got our lights on. Let's see if we can get any conductivity. Doesn't look like we're getting any. All right. Substance number 3. All right. Got it submerged in the salt, or it's not salt, I don't think, but whatever this is. No conductivity as a solid. Let's get some water into it. Okay, so this one looks like we're getting a teensy, oh, kinda. Can't make up its mind. So remember, like I said, sometimes we just get a little bit of dirt or a little bit of impurities and we're just getting barely a tiny bit. It's probably just dirt, right? It's not even super constant. So let's go ahead and say no on that one. Get to number 4. See if we can focus in here. Try the conductivity as a solid. We got nothing. Try it as a liquid. All right, this one's pretty obvious, right? We can see that's really different from that last one. We're up around 5. I'd say that's pretty significant. All right, we get to number 5. So for number 5, we've got this stuff. And we're going to go ahead and test its conductivity as a solid. So this one is the best, right? For the next part, we're going to go ahead and test the melting points for each one of these. So when we're doing the melting points, we're just basically going to rate them as having either a high melting point or a low melting point. And so the way that we're going to distinguish that is high melting points are usually things that are in the thousands of degrees, right? You're approaching 1,000 degrees or something like that. So when we're looking at our hot plate, when we turn our hot plate on, the maximum temperature that the hot plate can reach is 540 degrees Celsius, not 1,000. So what we're going to do is we're going to take each one of these samples that we have here, with the exception of number 5. Number 5's box should be crossed out. We're going to take each one of these samples and we are going to place them on the hot plate, which means we're going to bring them up to about 540 degrees. So if the sample melts, it means that it's melting at 540 degrees or less, which we're going to define as a low melting point. If it never melts when it's on this hot plate, it means it takes something much higher than 540 degrees, which we're going to call a high melting point. So in order to do this, I don't want to melt anything inside the beakers because it's really tough to get melted stuff out of beakers. So I'm just going to use a piece of aluminum foil. So I'm just going to take the aluminum foil and turn them into little bowls here. All right, so now I've got an aluminum foil bowl that I could throw away for number 1. Number 2. There's number 3 and one more. Okay, so we're going to pour a little bit of each one into the bowl. And I didn't label the aluminum foil, so I think what we can do for this is I could either get a Sharpie. Yeah, I'll get a Sharpie. I was gonna say we'll just keep them straight on the hot plate, but it's pretty easy for us to Sharpie it up here. So this is going to be number 1. This is going to be number 2. And 4. So we're going to go ahead and move over to the hot plate now, and we're just basically going to watch and see if these things melt. I'm just going to kind of put them in the same locations like as is clockwise. So 1, 2, 3, and 4. So we'll put 1, 2, 3, and 4. And if we look real close, you'll notice that this guy went into solution very quickly. This one's liquid. So we're going to go ahead and pull this off. We can see that that's a liquid. We can also see that this one has melted as well and is bubbling quite nicely. So we're going to go ahead and pull that one off. And these two just kind of sitting there. Yep, I'd say that those are not changing. They're getting nice and hot. At this point, they've got to be right around 540 degrees, but 1 and 4 just are not melting. Yeah. So I'd say 1 and 4 not changing on us, staying the way we saw them. So at this point, we should have all of our data, and you should be able to identify each one of these crystals as being ionic, covalent, or metallic, and give a little bit of evidence as to why. You should be talking about everything that we saw here in the lab today. Let me know if you guys have any questions.